It is all around us, powering our everyday technology, and we have an intimate relationship with it which we cannot avoid. Yes, I'm talking about electricity. Cell phones, computers, lamps, air conditioners, and heaters. It's tough to escape electricity in this modern civilization. You can't escape electricity even in the loneliest corners of the world. Do you hear that bolt of lightning? It's a massive surge of electricity between the sky and the ground beneath, enough to light 100 powerful lamps for a whole day. Those static sparks at your fingertips, and signals firing throughout the nervous system. You breathe, think, and walk, all because of electrical signals. But what exactly is electricity, and how does it work? Let's learn about that. To understand electricity, we need to understand what are atoms, one of the basic building blocks of the universe. Everything within the universe is made up of atoms, existing in different forms as chemical elements like hydrogen, helium, carbon, oxygen, and copper. Atoms combine to make molecules, forming matter, which we can see and touch. They are very small, each one measuring 1/10 of a millionth of a millimeter. To give you an idea, a copper penny would have 32 sextillion atoms, or a pinhead would fit around millions of them. Every atom has 3 distinct particles: electrons, protons, and neutrons. Within an atom is a center nucleus made up of protons and neutrons, densely packed together, while electrons are charged particles which revolve around the nucleus. Atoms must have at least one proton, and the number of protons defines the identity of an element. For example, an atom with 1 proton is hydrogen, an atom with 6 protons is carbon, 29 protons is copper, and the list continues. This count of protons in the nucleus is called the atomic number. Electrons and protons are charge carriers. Protons always carry a positive charge, and electrons a negative charge. Neutrons are neutral. They have no electric charge. In its stable state, an atom will have the same number of electrons and protons, and it's thought to be the same in the universe. Electrostatic force, also called as Coulomb force, is the attractive or repulsive force that operates between the charges. It states that the opposite charges are attracted to one another, and like charges repel one another. The amount of force depends on the distance between the 2 charges. Closer the charges, greater the force. And it's because of electrostatic force that electrons are attracted to protons and repel other electrons, holding the atom together. However, the electrons are not forever bound to an atom. Inner shell electrons are strongly attracted to the protons, but the outer shell electrons can be moved. With enough electrostatic force applied, outer shell electron can escape orbit of the atom and become free. These electrons on the outer orbit of the atom are called valence electrons, and this shifting electron allows us to move charge and create electricity. Let us take an example of a copper wire filled with countless copper atoms. Copper atom has 29 protons in the nucleus and the same number of electrons circling around it. With enough electrostatic force of the valence electron, either pushing it with a negative charge or attracting it with a positive charge, we can eject valence electron from the orbit, creating a free electron. Now, inside a copper wire, this free electron is pulled and pushed by surrounding charges. In doing so, it latches to a new atom. The negative charge of that electron ejects another valence electron from the atom. This free electron then floats through the space again, being attracted and repelled, finally latching to another atom, and the cycle continues. This is called electric current, a stream of charged particles such as electrons moving through an electrical conductor or space and is measured in ampere. This movement of charge is harnessed via conductors. Metals like copper, silver, and gold have free electrons and are not bound tightly to their parent atoms. They are the top choices for conductors, whereas elements with low conductivity are called insulators. Here, the electrons are more tightly bound to the parent atoms. Popular insulators are glass, rubber, plastic, and air. When charges move constantly from one place to another, it is called current electricity. What if charges gather and remain at rest? Yes, you guessed it right. It is called static electricity. Static electricity exists when there is a buildup of opposite charges on the surface of an object, separated by an insulator. This charge remains until it finds a way to be released. Lightning is also caused by static electricity. As rain clouds move, ice crystals which are negatively charged sink to the bottom, while the water droplets which are positively charged move to the top. When the clouds gather enough charge relative to another group of clouds or the ground, it leaps as a bolt of lightning, charging massive quantity of negative or sometimes positive charges. As opposed to static electricity, current electricity is dynamic, and it requires a circuit made of conductive material through which current can flow. Circuit is usually composed of individual components such as resistors, transistors, and capacitors, which controls the flow of electricity. But one question remains: how do we induce the flow of electrons in the first place, and how do we keep them flowing? Well, let us learn about electric field, electric potential energy, and the potential difference. We all know that gravitational fields exist around the Earth, and gravitational force arises from gravitational field, attracting other objects of mass. Similarly, electrostatic forces arise from electric fields, attracting and repelling other objects of charge. The direction of electric fields is always defined as the direction of a positive test charge which would be pushed if it was dropped in the field. If a positive test charge is dropped near a negative charge, it would be attracted towards a negative charge. Hence, a negative test charge has an inward electric field, and the positive charge has an outward electric field, pushing away like charges. Electric field exerts force on other charges, inducing the flow of electrons. To understand electrical potential energy, think of a ball placed on top of a tower which has a lot of potential energy or stored energy. Once released, the ball accelerates towards the ground, converting all of its potential energy into kinetic energy. And when on the ground, it has very low potential energy. Similarly, electrical potential energy is the stored energy a charge has. Just like the ball placed on the tower, a positive charge close to another positive charge has high potential energy. And if left free, the charge will be repelled and will move towards the negative charge, just like the ball falling towards the Earth. A positive test charge in proximity to a negative charge will have low potential energy. In an electric field, there's a point of high potential where the charge has the highest possible potential energy, and a point of low potential energy where the charge would have the lowest possible potential energy. Voltage is simply the difference in the potential energy of the charges, also known as electric potential difference measured in joules per coulomb. Batteries act as an energy source converting chemical energy to electrical energy. It has two ends, a positive terminal called the cathode, with excessive positive charges, and a negative terminal called an anode, with excessive negative charges. The electric field will influence the electron to move from atom to atom, pushed by the negative terminals and pulled by the positive terminal of the battery, thereby creating the flow of charge called electricity. And every time charge moves through the light bulb, they lose their potential energy, converting electrical energy to heat. And as the charge moves through the battery, they gain potential energy. This powers your everyday appliances, and life without electricity is difficult to imagine. It is extremely useful, but don't forget, it is dangerous as well. Thank you for watching this video, and if you really think you learned something interesting today, hit that like button and subscribe if you are new. Until then, stay happy, stay curious.